4. Okay? So you asked about a couple of the definitions, so we'll talk about definitions. Okay, the first part up there is just polygons. Make sure you understand that we're always going to be finding the area of a regular one, so all the side lengths are the same, all the angles are the same. Okay, in order to accomplish what we want, you have to understand what the radius is and the apothem and the central angle. I wasn't going to define center. If I asked you for the center of that pentagon, would you know what it is? F. Okay, so we know what the center is. So the radius. The radius is a line that goes from the center to a vertex. Okay, so an example of that is AF is a radius, BF is a radius, CF is a radius, DF is a radius, FE is a radius. So from the center to a vertex. And when we eventually get into the concept of finding missing values, this is going to end up being our hypotenuse. Okay, because we're going to talk about right triangles. All right, the apothem goes from the center to a side, and it is perpendicular to the side, and it bisects the side. So essentially, it is the perpendicular bisector of the side. So that means that BG is congruent to GA, and they already have the right angle symbol in there. So our apothem is FG.
Is it line or line?
It's a line, so it's a line or a line segment, sorry. Because it starts at the center and then it ends at the side. Okay? And then your central angle is the angle, in terms of what we're going to talk about, is the angle formed by two consecutive radii. Okay, so in the picture, angle BFC is a central angle, CFD is a central angle, DFE is a central angle, AFE is a central angle, BFA is a central angle. So in the pentagon, how many central angles are there? Okay, you need a drink?
I don't.
Okay. How many central angles are there? 5. Okay. Can anyone come up with a way to find the measure of the central angle? Thank you. Find the measure of the central angle.
I got you. Don't you take like the 540?
Oh yeah, I know what you're talking about. That's good. You were thinking of the sum of the interior angles, okay? But just so you know, that's the angles out here at C, D, and E. We want the ones at the center. So what's the distance around the center?
360.
There you go. How many angles? All right. So essentially, it is going to be 360 divided by the number of sides. Okay? So that's going to be the important piece. Okay? All right, so do we need help finding the measure of the central angle?
Probably.
Probably? All right, so let's do example 1 together then. Okay? It says to find the measure of angle AFB. Okay? So we got to find the measure of AFB. We want this big angle right there. Ideas?
Well, 45, 45, 90.
Not 45, 45, 90. You're assuming something.
30.
No, again, you're making an assumption.
45, 45, 90.
No.
360.
360 divided by 5. 360 degrees divided by 5 sides gives us that central angle of 72 degrees. Okay? Then, what we want to do is we want to find the measure of this angle, AFG. So we talked about GF is a perpendicular bisector, so it does something to that angle.
Is it 72
Cuts in half.
divided by 2?
It cuts it in half. It's 72 divided by 2, which is
66.
36. So now we got to find the measure of angle GAF, which is this angle down here.
Yeah.
Okay? So if you think about this, we know this angle is 90 degrees.
Oh my god.
We know that this angle is 36 degrees. Can anybody come up with this angle down here in the corner?
That's really loud.
Knowing that this is a right triangle, Jesus is telling me that it's 54.
Well, he's correct,
Why is he correct?
because 90 plus 36 is 126, and 180 minus 126, knowing that a right triangle has to equal 180 degrees with its interior angle, is 54.
Okay, so that's the long-winded version, okay? Didn't you learn that the sum of the two acute angles of a right triangle are complementary? They add up to 90 degrees? So couldn't we just do 90 minus 36 and get 54?
I've never learned that.
You never learned that?
I never
Well,
learned that either.
there you go, you just learned it now, okay?
What did you say?
So in a right triangle, the two acute angles are always complementary. So 30, 60, 45, 45, in this case 36, 54, 70, 20. The other two, the non-right angle will always, non-right angles will always add up to 90, okay? Okay, well, if anything, know the sum of the angles is 180, okay? All right, so do we need to practice finding central angles some more?
Do you want us to? Because I got a few more minutes.
Okay,
Yeah, I got all day.
so find the central angle for a regular heptagon. And then round it to 1 decimal place.
That's funny.
51.4
Okay?
degrees.
He says 51.4.
Wait, what did you question us?
I just asked you to find the measure of the central angle of a regular heptagon.
That's impossible.
No, it is not.
She's
Hi,
leaving.
Grace.
I know.
Hi.
You can't just leave.
Have a good day.
So do you not know how to find the 51.4?
No.
Okay. We said the measure of the central angle is 360 divided by the number of sides. How many sides does a heptagon have?
5.
Try again.
5.
Try again. 7. So he did 360 divided by 7, and he got 51.4.
Ah.
Okay? All right, so let's try it again. Take the hexagon. Find the central angle for the hexagon. 60? 60? 60. All right, so then the next part that we're going to do is we are going to cut these central angles in half because we want to create right triangles, so that top angle will end up being a 30-degree angle. So that means if I ever need to find a missing value in this 30-degree triangle, what concept would I use? 30, 60, 90. Over here, if I create a right angle, okay, with my apothem, and then I go and figure out this angle measure, what concept would I have to use in order to find a missing side length?
Oh, boy. Awesome.
90 minus.
Why not 30, 60, 90?
Wait, what was
I asked if I wanted to find a missing side length, you said SOHCAHTOA. You're correct. Why not 30, 60, 90? Yeah, why not 30, 60, 90? Because you don't have a 30-degree angle. Angle is actually going to end up being what? 25.7, right?
That's correct.
Okay, 25.7. So we're going to have to use SOHCAHTOA. Okay, if I had a 45-degree angle there, I would use 45, 45, 90.
You can use 180 minus 90.
Wait, how do you,
Yes.
yeah, how do you get 25%?
We took the 51.4 and divided by 2.
Oh, no.
Okay? All right, so let's take a look at what that would look like, okay, where they don't give you all the information. So go down to example number 2, okay? They say find the area of a regular hexagon. So I'm going to draw a hexagon, 6 sides. They did tell me the side length was 3. Okay, I like to always start out with my area formula. Area is equal to 1/2 AP. Okay? Then I like to fill in what I know. Do I know the value of A?
No.
Do I know the value of P?
Yeah.
You can.
Okay, so what's P equal to?
3. 18.
It's not 3.
18.
Why 18?
Because it's
3
3
times
times
6.
6.
Okay? If you're not understanding, it's 3, 3, 3, 3, 3, or 3 times 6. Okay, for P equal to 3 times 6, we get 18. Alright, so now we have to figure out the apothem, okay? So in order to do that, our goal is to create a right triangle with the apothem and radius. Okay, so I'm gonna draw in, here's my apothem, here's my right angle, here's my radius. Okay, and then what I need to do, the reason why I did that is I want to find the central angle. So what's the central angle in this case?
120 degrees.
Try again.
Why?
60.
Explain to him why it's 60 and not 120 degrees.
Divide by 6.
Lie.
Why do we divide by 6?
Because it's empty.
There are 6 sides, so 360 divided by 6 equals 60 degrees. Okay? 2, cut it in half.
Oh, ha ha ha. So,
Okay, because the 60 degrees goes from radius to radius, but we don't want that angle, we want half of it. So what is that?
30 degrees.
30 degrees. Okay, so that angle is 30 degrees. Okay, so I'm going to blow this up here. So if I now want to find the value of the apothem, which is right here, how can I do that knowing this side length is 3 and this angle is 30?
Divide it to 30, 60,
30, 60, 90, very good. So what's A? Not 6, try again.
3
Not 3 root 3.
Regular 3.
Let's start with this, okay, since we're getting stuck here. What's this length? It's not 3, it's 1.5. Because we said that the apothem cuts the side length in half. So now what's the apothem?
1.5.
There you go. It's 1.5 root 3. Because remember, the short side is x, the side opposite 60 is x root 3. Do we need to know the value of the radius? Do we need to know the value of the radius? We do?
No, not really.
No, we don't. Okay? So we don't have to figure out the length of the hypotenuse in this case. Okay? So now that I know that the apothem is 1.5 root 3, I can put in a 1.5 root 3 here, and then I can go and find my area by typing in 1/2 times 1.5 root 3 times 18. And since we have a decimal here at 1.5, why don't we just type this all into our calculator and go to 1 decimal place? In general, if we have decimals, then in our question, we can come up with decimals as our answer.
23. Yeah.
23.4.
4.4.
let's see if that's correct.
Yes.
I've got 4 people that said 23.4.
I would say 23.4.
23.4 meters squared. Anybody need help getting the 23.4? If you're not getting it right, my suggestion would be check to see your root 3. Sometimes there's a parentheses here, and you might have to close your parentheses after the root 3. Because otherwise you're taking the square root of 3 times 18. Okay? All right, so in general, the goal is to essentially create a right triangle. Use the concept of right triangles in order to find any missing parts that we need, whether it's the apothem or a side length. So in the next 2 examples, we're going to find the missing side length. Okay? In this case, we use 30, 60, 90. In another case, we might use something else. So let's go to page. Okay? All right. So on number 3, we have to calculate the area of the regular polygon. Okay? So if I start with my formula, area equals 1/2 AP. Do I know what A or P is?
P is, I mean A, but
What's A?
6.5.
Okay, so you're supposed to recognize that 6.5 is the apothem, so 6.5 is A. Okay, do we know what the P value is? Can we get it as easily as we did the last time?
Yeah.
Like the last time they gave us the side length was 3 and we just did 3 times 6.
That's impossible.
I mean, Since we know that it's a pentagon, we know that it's got 5 sides. So
True.
This is 360 divided by 5.
Well, that gives us the measure of the central angle, not the perimeter.
Oh, yeah, yeah.
Oh, yeah.
Whoops.
Okay.
Well, it's a penta.
All right, so, remember, we said the goal was to create a right triangle. They already gave us a right triangle. The reason why we want the right triangle is so that we could find the length from here to here. Once we know that length, how can that help us find the perimeter?
So we can find the central.
We don't need the central angle in this case.
You would times the answer by 2.
So what were you saying? Okay, so she says, once we figure out that, double it, because that'll give us the whole side length. And then once we know the whole side length, multiply it by the 5 for 5 sides. So how can we find that little piece there? Any ideas?
Pythagorean.
Why Pythagorean theorem?
You have both sides.
Because we have 2 side lengths. We didn't have to use 30, 60, 90, 45, 45, 90 or trig. So find that little piece to 1 decimal place. Did you round appropriately? All right, so we got a 4.7.
4.7.
4.7,
4.7.
because it's the square root of?
21.675.
Correct. Okay? Does anybody need help getting, by doing x squared plus 6.5 squared equal to 8 squared, getting x equal to 4.7? All right.
The square root of 22.09.
21.07, 0.75 I mean. Okay, so this is 4.7. So now, what is the side length of the pentagon? 9.4. Okay, and the only reason why we want to know the side length is so that we can figure out the perimeter. So what's the perimeter equal to?
47.
47. And the reason they got 47 is 9.4 times 5 sides. All right, so now we have everything we need. 1/2 of A times P. So what's 1/2 of 6.5 times 47?
152.
I got a 152.75 up here.
I also have a 152.77.
All right, so we got a 152.75, and we'll go units squared since they didn't give us units. Okay? So, 3 ways that you can use in order to find a missing value in a right triangle. What's 3 ways? All right, so we just used the Pythagorean theorem, so one of them is the Pythagorean theorem. What else?
30, 60.
Okay, so 30, 60, 90, and we'll throw in 45, 45, 90 in there. And then Lev said the third one, which was
Trigonometry.
trig. Okay, so you got to use one of those concepts in order to find missing values sometimes. Okay, sometimes they give you everything you need, like the very first 2 examples we did. All right, so let's do one more. Okay, since we've already done one with Pythagorean theorem, the one above, we did 30, 60, 90. That was example number 2. So now let's do one with trigonometry. Okay, so we're going to skip number 4 and go to number 5. Find the area of a regular octagon with a apothem of 8. Okay, so if I draw my octagon, draw in my apothem. Okay, and then I write my formula. Area equals 1/2 AP. What do I know already? I know A. What's A? 8. So that means we got to figure out what P is. Ideas. Reminder, we said the goal is to create a right triangle. Do we have 2 side lengths?
We have 1.
We have 1. We don't have 2, so we can't use Pythagorean theorem. So if we don't have Pythagorean theorem, that means we better find an angle measure. Any ideas on finding an angle measure? Okay? 45, 45, 90, trig.
SOHCAHTOA.
So how do we know if we're going to use 45, 45, 90 or trig?
If we have an angle, if we have an angle measure.
If we had an angle measure. All right, how can we get an angle measure? 360 divided by 8. What's 360 divided by 8? 45. Now, reminder, 360 divided by 8 gives us the angle from blue to blue. We don't want the angle from blue to blue, we want the angle from red to blue. So what do we do with that 45-degree angle? Divided by 2, giving us, all right, so if the top angle of this right triangle is 22.5, are we using 30, 60, 90? 45, 45, 90? We don't have two side lengths, so we're not using Pythagorean theorem, so therefore we're using trig. Are we going to use sine, cosine, or tangent?
Tangent.
Why tangent?
Oh, because it's opposite over adjacent.
Okay, we want to find this little piece down here so that we could find the perimeter. And he says this is our opposite and the apothem is our adjacent, so he wants to use tangent. So tangent of 22.5 is equal to the opposite over the adjacent. In this case, that's 8. Cross multiply solve, x is equal to 8 tan 22.5. For right now, just go to one decimal place.
3.3.
3.3, what'd you get?
Same thing.
Same? 3.3. All right, so remember, that's the distance from the red to the blue. That's 3.3. What's an entire side length? 6.6. All right, if a side length is 6.6, then what's the perimeter equal to? 6.6 times 8 sides, which is 52.88. Okay, so now you've got 1/2 of 8 times 52.8. What's the area? 211.2
Oh,
are
it's
your
inches. It's
inches, so inches squared. All right. So based upon what we just talked about, okay, this is where you can now write it down. Area is equal to 1/2 of AP. That's the formula we're going to use to find the area of any regular polygon. So based upon the picture that we see, do we know what the A is or the P? Little a is the apothem. It's that little line that goes from the center to the side and forms a right angle. We'll define this later
Isn't that
on.
just the radius?
Radius, okay, so we didn't do the definitions yet. We're gonna get to it. This is gonna be the radius. This is gonna be your apothem. So what's the apothem? 6. So A is equal to 6. Does anybody know what the perimeter is?
It's 8 times however many.
How many are there?
40. The
Okay,
perimeter is
so
40.
there's 5 sides, 8, 8, 8, 8. So therefore, our formula becomes 1/2 of 6, the apothem, times 40, the perimeter. Okay, what's our area?
Wait, so area, so 40 equals 6 times what?
Well, it's just 1/2 AP, so 1/2 of
P.
P is the perimeter. Okay, so Jesus has 120. Does anybody agree? 120? 120? Okay, so it's 120, and that'd be centimeters squared. Okay? So the only two things you need to know are the apothem, that's going to be that line that goes to the side and forms a right angle, and then the perimeter. Okay? So to check for understanding, let's do the following. I'm going to give you an octagon. Okay? And let's say that I give you this here is, we'll say 8. And then I tell you that one of the side lengths is a 6. How would you find the area?
Around this. Or no, technically.
The idea is to use the formula I just gave you. He's already got 192. 192. So how'd you get that, Arian? And where'd your 48 come from? Okay, so A she figured out is 8, because that's your apothem. And then P she figured out was 48, because 6 sides, or 6 times 8 sides. Okay? And then, so then she multiplied that together, and she gets 192, and since I didn't give you any units, you would just say units squared. All right, questions so far?
No, ma'am.
No, ma'am.
We good? Okay, so that's the overall concept. Now we gotta get into the nitty gritty. The nitty gritty is the fact that sometimes they won't tell us what A is, we have to figure it out. Sometimes they won't tell us what the side length is, we have to figure it out.
Thank goodness.
So, you're excited about this idea, aren't you? We're gonna possibly have to use 30, 60, 90, or 45, 45, 90.
Definitely.
Or how about Pythagorean theorem,
Do we
okay?
have to give our tests back now?
No, we're fine.